Hello, everyone. Today I'm here to talk to you about bringing true scalability to Ethereum with Fuel. A little bit about me. My name's John. I'm currently with Fuel Labs. We're the leaders in blockchain scalability R&D, and we're building Fuel, which is the most scalable optimistic rollup on Ethereum. Previously, I was a Consensus doing layer 2 scalability research, and I created the optimistic rollup design paradigm while I was there. So before we talk about true scalability, let's talk about the scaling problem, what scalability means. Ethereum is limited to about 15 transactions per second, or it can do maybe 30 if you're talking simple payments. But more specifically, it can do about 1.3 million gas per second, irrespective of how many transactions that is, because transactions could be complex. And the problem is that we want to increase transactions per second, which is called throughput, without decreasing decentralization. And we call this thing scalability is transactions per second divided by decentralization. So it'd be pretty easy to increase transactions per second if you decrease decentralization, but that's not scalability. We really want scalability. So what is decentralization? We said what throughput is, transactions per second. What is decentralization? First, what decentralization is not. A common talking point is that so-called centralized blockchains, like EOS, let's say, just as an example, the common talking point is they have much more throughput than Ethereum because they're centralized around a small number of validators. Let's say EOS has 21 block producers. But this is wrong. That's not why they have a higher throughput. If it were the case, as you can see in these diagrams on the right over here, Ethereum and Bitcoin, you would expect them to have more transactions per second than Ethereum because they have a smaller number of mining pools, essentially. Ethereum, 4 mining pools have more than 51% of the hash rate. Bitcoin, 4, maybe 5 mining pools have majority of the hash rate. 4 and 5 is less than 21. So if it was just about the number of nodes, you'd expect Ethereum and Bitcoin to be able to process much more transactions. But they don't, because consensus is not the bottleneck. Something else is. What is decentralization? On Ethereum, we want a user running full node on approximately the specs, a 4-core CPU, 8 gigabytes of RAM, and an NVMe SSD. We want them to be able to fully validate the blockchain at a rate approximately 100 times as fast as it grows. And this is called initial block download. We want to be able to catch up to the tip because otherwise you would never be able to actually fully validate the chain, right? On EOS, the specs for a full node are much, much higher. You would expect something like a 64-core CPU, 1 terabyte of RAM, rated NVMe SSDs, all that jazz. And you'd not even be able to catch up to the chain. You would just be able to validate as it goes. But as soon as you go offline for a second, then you're done. You can't catch up anymore. So decentralization is actually the cost to run a full node for the user. And we need this, and this is critically important because if we aren't sure that block producers aren't including invalid transactions that give themselves, $1 billion. If we don't know this isn't happening, we don't have control over our money, right? People can just inflate the supply of the coin infinitely, and we wouldn't know. In order to have control of the money, we need to be able to validate the supply of the token and to make sure all transactions are valid. And this is a social contract. It has nothing to do with the consensus protocol. It doesn't matter if you're using proof of work, proof of stake, BFT, chain-based, Avalanche, EOS, DPoS. It doesn't matter what you use. Consensus protocol is completely irrelevant. Decentralization is the cost to run a fully validated node. Okay, so now there's decentralization, but how does this manifest in terms of a bottleneck? Right, Ethereum can do 15 transactions per second on the aforementioned hardware, but why is it 15? Why isn't it 150? Why isn't it 1500 on this hardware? Right, we're not talking about increasing the hardware here. We've already fixed our hardware requirements. The reason it's 15 is because of EVM execution. It's complex, it's costly. You can do really complex smart contracts, but the real big pain point is around state accesses and state growth. The Ethereum state is currently around 100 gigabytes, and this is in a Merkle tree, which means you're doing a bunch of random disk reads every time you try to write or read from a state. And this is why you need an NVMe SSD. Even a regular SATA SSD is going to have a really hard time doing this. So the state of a chain is, the things like account balances, contract stores, and stuff. And this needs to be kept around by all full nodes. If you don't know everyone's account balance, you can't validate new transactions. You can discard historical transactions, just like the actual transactions themselves, but you always need to keep around state. It can't be pruned. So things like state growth are also very important. You don't want this state to be 1 terabyte, because then all full nodes will be a minimum of 1 terabyte in size, which is really bad. Okay, so rollups to the rescue. Rollups have a very convenient design paradigm, which is while you move state and execution off-chain, and you just use Ethereum for data availability. This seems like a really, really good idea, because now rollup nodes only need to make data available and order it, which is very cheap, but they don't execute transactions, and they don't have state accesses or state growth based on those transactions. So this is very powerful, because you can't do less execution than no execution. This seems like it's potentially a huge amount of scalability, but there's a caveat here, which is that rollups are still blockchains. And as we said before, the decentralization of a blockchain, and the whole reason that blockchains are self-sovereign, is that users can fully validate the state of the chain to make sure that it's not invalid, right? We don't want to trust the big bank to tell us whether or not a chain is valid or not. We want to be able to determine that ourselves and verify that ourselves, right? Verify, don't trust, as opposed to the opposite. So if everyone were using a single EVM rollup, which, if we remember, that is the bottleneck of execution on Ethereum, you wouldn't be able to get 780 transactions per second, as you see here. You would be able to still only have 15 transactions per second on the single EVM rollup, unless you want to decrease decentralization, unless you want to make users have less sovereignty over their money. This 780 transactions per second is not the amount of transactions that a single EVM rollup can process. Rather, it is the it's the amount of data availability throughput that the Ethereum chain could support. So it could support a total of 780 transactions per second across multiple rollups. So you could do a form of sharding, if you want to call it that, where you have 100, 15, or 50 rollups that are running 15 transactions per second each. That gives about 780, if my math is right, give or take. So you could do something like that, but you wouldn't be able to get a single EVM rollup at anything more than 15 transactions per second unless you're sacrificing decentralization, which we don't want to do. How is Fuel different than an EVM rollup? It's specifically built around a different execution model than the EVM, and this execution model is more scalable. Specifically, the core ideas of all iterations of the Fuel blockchain are that we're using the UTXO data model as opposed to the accounts data model. So this is similar to Bitcoin as opposed to Ethereum, and this means you can do parallel transaction validation. And we have an efficient fraud-proof scheme that doesn't involve a global state root or a global state tree. So the Fuel V1 blockchain, it was the first optimistic rollup deployed on mainnet Ethereum. It was deployed last year, actually. It is currently the only optimistic rollup without upgradability, so it's fully trustless. It's also the only optimistic rollup, to the best of my knowledge, with permissionless transaction inclusion. So it's both fully trustless and fully permissionless. Now, it's very, very maximally efficient, and because of its parallelizable execution model, and because it doesn't do smart contracts. It's only for simple payments. Can we do better? Yes, we can. This is where Fuel V2 comes in, and this is where it brings true scalability. Fuel V2 will have full Ethereum-style smart contracts, but also in the UTXO data model. So with the UTXOs, we get highly parallelizable transaction validation, but we also get the nice way that Ethereum does smart contracts versus other more obtuse ways, like what Solana has, for instance. By coincidence, we also have a much more flexible transaction model that allows you to do many more interesting things than what Ethereum does. We also introduce a Rust-based smart contract language, which is called Sway. You can watch the talk here that's linked at ETHCC. Alex gave a talk on Sway to introduce it. This allows users to write more secure, higher performance smart contracts much easier, and it introduces many things that Solidity does not have, like traits, generics, enums, spilling, so that you can have more than 16 local variables, macros, zero-cost abstractions, extensive standard library, and so on. So how do you stay up to date with what we're doing? You can follow me on Twitter at @jadler0. You can follow us at fuellabs_. Here's our website and our GitHub. And most importantly, if you're a Rust, TypeScript, Solidity, or if you're non-technical, that's fine. We're hiring both technical and non-technical positions here, and you can click on the link here, or you can DM me on Twitter. We're hiring. Thanks.